ये मैं उनके जरा उसके ऊपर भी ऐड कर दूं जो नहीं आ रहे। अच्छा, सो करेंगे ये कि we'll try and just get done with salt preparation. Just अच्छा, so we're gonna try and just be done with salt preparation this class, ठीक है? So it's just going to be a longer class. कहाँ तक हम पहुंचे थे? We had एक सेकंड, ये बोर्ड में खोल लूं। चलो हिबा, आपको बोर्ड नजर आ रहा है? Can you see the board? मास नजर आ रहा है बोर्ड?
Yes.
अच्छा, so last thing that we did was we did a bit of titration, and I had explained to you. Okay, just hold on, give me a second. So I had explained to you that what titration was. So we're going to do the third method of salt preparation in just a moment, and before doing that, and we'll even start past paper questions related to this. So what we had done was we had talked about, I mean, start see, okay? Just a quick recap. Starting from scratch, we had learned about ions, and we had talked about four methods of four reactions in which salts could be prepared. One was the metal plus acid reaction, and only Mazet metals could be used: magnesium, aluminum, zinc, iron, and tin. You had a metal oxide, metal hydroxide reaction with an acid to produce salt. You had a metal carbonate reaction with an acid to produce salt, and you had ammonia plus acid reaction to produce ammonium salt. That was one thing. And then we learned how to make these equations. Like if you want to make magnesium nitrate, what you're going to do is you're going to take nitric acid. ठीक है, वो उसके अंदर से पता लग जाता है कि it's going to be nitric acid. The metal will be either magnesium, or a metal oxide could be used, even a hydroxide, or a metal carbonate. In each case, the byproducts are going to be different. So we learned aluminum chloride banana, so it's going to be HCl, that's the acid, metal oxide or hydroxide, and a metal carbonate. All of them could be used to make aluminum chloride. And we learned about the solubility of salts, TK, that's all written over here. And then we started talking about the method of preparation, which was that the first one was excess method. उसमें क्या होता था कि no matter what the equation is, if the reactant is insoluble, like magnesium is a solid, it's a metal, and the salt that you're trying to produce is a soluble salt. So you're going to use the excess method because you're going to put magnesium in large excess. And when you put magnesium in large excess, the solution में जितना भी acid and HCl, that's all going to get used up. And your solution will only have the salt. So the solution will only contain the salt, and it will not be contaminated by anything, except that there's going to be a piece of magnesium that will still be left because you're adding too much of it. उसको आप आराम से remove कर सकते हो. You can filter it out at any point, ठीक है? And we learned about how to write that, ठीक है? Then we did titration. Titration में क्या था कि you have soluble reactants, and the salt that you're trying to make is also soluble. Now, in titration, the biggest issue was that जो मसला था, that was कि you can't use the excess method, because if you put NaOH in excess, your salt will be contaminated by the excess NaOH. Soluble चीज को आप निकाल नहीं सकते, ठीक है? I gave you an example of mixing Coke, Pepsi with tea. If they get mixed up, you can't remove them because they both are soluble. HCl added in excess, you can't remove it from the salt that gets produced. So what you instead do is to ensure that none of the reactants, either HCl or NaOH, are added in excess. You take the NaOH in the burette, or you could have taken the HCl in the burette as well. You take the HCl in the flask over here. You start adding NaOH drop by drop. The moment all the HCl reacts, that is the point where you should stop. So how do you know when to stop? Because you can't see the particles. So I told you that initially you have acid in the flask, so your solution will be highly acidic. Then it will turn into, all the HCl will react and it will form the salt, which is NaCl. So वो neutral हो जाएगा. And that's the point. That will indicate that the acid has now reacted. So you should stop. If you don't stop at this point, you're going to add. As if you don't stop at this point, what is going to happen is you're going to add excess NaOH. Extra NaOH is going to go into it, and that will make this salt basic because it's going to be contaminated by extra NaOH. You don't want that to happen. So indicators will tell you when the solution is neutral. Acidic in the methyl orange is red, and in basic it's yellow. So as soon as the color changes, that will indicate that if it becomes yellow, that means you've started adding too much NaOH into it. So you should stop. और फिनोफ्थलीन के अलग कलर्स थे, ठीक है, तो ये सब हमने किया था, ठीक है. ये सब तो क्लियर है ना? इज दिस क्लियर?
Yes.
अच्छा, तो we did all of that, ठीक है. So now the other thing is we're going to move to the next part, the third part, ठीक है. So now this third part is known as, the technical name is ionic precipitation. You can remember that's our third and final part. So what really is ionic precipitation? And it's a method of preparing salts that are insoluble. So specifically, you're going to make insoluble salts. You're going to take soluble reactants and using those soluble reactants, what you're going to do is you're going to make soluble salts. So that is what's going to happen. So what? I said not soluble salts. ये गलत हो गया. Insoluble salts. It's a method for making insoluble salts. Just a second. So you can look up the many salts which are insoluble. For example, a lot of carbonates which are insoluble. TK, if you look at the solubility table. So for example, if I want to make calcium carbonate. Now, firstly, I'm just going to focus on the method. So if I want to make an insoluble salt, what exactly am I going to do? Every time it's going to be something like this. Now, this is a new equation. It's an ionic precipitation equation. So it's got nothing to do with the equations that you've studied already before this. अच्छा, calcium carbonate बनाने, you need two things. You need calcium ions to come from somewhere, and you need carbonate ions to come from somewhere. Okay? So that's the basic idea, that you need something that contains calcium ions, and you need something that basically contains carbonate ions. But they've got to be soluble, and I'll give you the reason later on. But they have to be soluble. So I'm looking for a calcium compound, because calcium ion akela to nahi ho sakta. It can't be alone. It has to be next to a negative ion. It must be some sort of compound. So I need to focus on the fact, okay, I would need the solubility table, okay? So here's a solubility table. Now we need something that's got calcium ions and that's soluble. So here's one. Okay, chlorides are all soluble, so I can have calcium chloride. Carbonates and phosphates are mostly insoluble, so forget that. Calcium sulfate is also kind of not very soluble, so I want it to be soluble. So I guess the only option, calcium oxides and hydroxides, yep, that's also partially soluble. So That's not going to work. So I guess I'm only left with chloride. I'm also left with nitrate as well. Like यहाँ पे लिखा होगा nitrates. All nitrates are soluble. So I can pick calcium nitrate. I can pick nitrate to go along with calcium. I can pick chlorides to go along with calcium. So if I go back, I need a calcium compound that is soluble. So let's go with chloride. It's Cl is -1. Solubility table कह रहा था कि all chlorides are soluble except for silver and lead. So all of them are soluble. So it's going to be calcium chloride, CaCl2. Or it could have been calcium nitrate as well. Calcium is +2, NO3 is -1. So it's going to be calcium and NO3 twice. But the idea is it has to contain calcium and it's got to be soluble. The other one is a carbonate. Now, as I remember, a negative ion is going to be next to a positive ion. So carbonate, I need a carbonate compound that is soluble. So let's go back and look at the table. So if I look at the table, I need what I need is a soluble carbonate. So यहाँ पे लिखा है all group 1 compounds are soluble. All of them are soluble. So if I take a group 1 compound, it's going to be soluble. So let's go back. So let's think of potassium. Potassium is group 1. So group 1 is soluble, K+1. So it's going to become K2CO3, or it could be any group 1 compound. वो NH4 वाली चीजें भी सारी soluble थी. I mean, the table said that all ammonium compounds are soluble as well. So I could pick ammonium carbonate as well. Who else is in group 1? I can pick sodium as well. That's going to be soluble as well. So carbonate is -2 and it's going to be Na2CO3, okay? So is this part clear, the first part? Okay, forget the reasoning में explain करता हूँ why I'm doing this part. Is that part clear that you need 2 compounds and you want both of them to be soluble. You want both of them to be soluble. If you're making calcium carbonate, you need calcium to come from somewhere, you need carbonate to come from somewhere, but it has to be a soluble compound. Okay? So that calcium or carbonate could come from calcium chloride or calcium nitrate, or carbonate could come from all of these options. Okay? Is this clear, the first part?
Yes.
So now, what's the logic behind that? Why do we want that to happen? So what happens is, let's say I'm taking calcium chloride I've got, and on the other side, I've got this other one, which is just a second, calcium chloride. I've added calcium chloride to the beaker. And from the other side, I'm also pouring in consavala potassium carbonate. And that is also soluble. So I had explained to you that you just salts when these salts, they mix in water. And if they are soluble, like NaCl is very soluble, where does it disappear? What happens is the whole crystal, it scatters, it dissociates. So calcium chloride ko agar aap pani mein mix karoge na, so calcium ions and your Cl ions, they're all going to dissociate. So you will have Cl ions floating around, you will have calcium ions floating around, you'll have more Cl ions floating around, okay? So this is what happens, okay, when you add salt, or calcium chloride, that's a white colored salt. This is what it looks like. Calcium chloride salt. So exactly seal ki tarah. And when it mixes in water, it's also aqueous. Maybe see barium chloride kyun ho gaya? Calcium chloride. But it's exactly the same, almost the same thing. So for some reason, barium chloride में कुछ change होता है
Sir,
calcium
it's
chloride.
because that's what people also search for. You'll have to go into images.
अच्छा ठीक है मैं भी कहूँ क्या हो रहा है. So you see calcium chloride similar to I mean all your chalk etc. table salt. They're all these white colored crystals, right? Small tiny crystals. Okay, you can see the crystals, but they are soluble. I mean these crystals are soluble. That means the ions which I mean, calcium chloride, all the small tiny ions, they'll all scatter in water and they'll disappear inside water. That's what happens when you mix NaCl as well, right? That's called dissociation. TK. Is this part clear? The first part, calcium chloride mixing in water, right? Clear?
Yes.
Okay, now similarly, you've got potassium carbonate, and that's okay, potassium carbonate will look exactly the same. TK, it's also a crystal bunch of ions sticking together. So images में जाऊंगा हाँ. ठीक है, so you can see potassium carbonate is kind of almost the same. So it's basically lots of ions all sticking together forming these crystals. पानी में mix होंगे तो they'll all scatter. They'll all get scattered and you won't be able to even see them. ठीक है, so they'll all of a sudden immediately disappear. So anyways, here's what's going to happen. Potassium carbonate will dissociate as well. It's going to break down and it will become potassium ions, carbonate ions, potassium ions, carbonate ions, all floating around, right? Is that clear? Okay, so the idea is both salts have completely mixed in water. Okay, is this clear?
Yes.
Now what happens is when you mix two soluble salts, now the ions will randomly combine with each other. Now a few of those ions are insoluble actually. Like if calcium ions and carbonate ions get together and they form a crystal, that crystal is not going to be soluble. Calcium carbonate is chalk. Chalk जो होता है ना, that is not soluble. It does not dissociate. उसको आप calcium carbonate is also marble. Marble is the same thing. ठीक है. So calcium carbonate, which is limestone, marble, or chalk, it does not dissolve. There's a reason for it why it's not dissolving because the ions very strongly attract each other. So they don't mix in water, they don't scatter. ठीक है, so that's why it's insoluble. ऊपर टेबल देखोगे ना तो उधर भी ना ये लिखा होगा कि that's insoluble, it does not dissolve. So all these calcium ions and carbonate ions will kind of get together and they'll form these solid precipitates crystals back again. The potassium ions and chloride ions, they won't attract each other, so they'll kind of just float away in water. They are very, very soluble. Group 1 compounds, chlorides are all soluble. Okay? So is this idea clear that precipitates would form and you'll start seeing solid deposits at the bottom?
Oh wait, so why would the calcium and the carbonate move together?
Because they're insoluble.
Okay.
And one of the reasons why things or these salts, some of these salts are insoluble is because their ions really strongly attract each other, so they don't dissociate. Do you get the idea?
Yes.
तो होगा ये कि शुरू में तो चलो mix हो जाएंगे because calcium ions are coming from some other salt, carbonate ions are coming from some other salt, but when they see each other, they're going to strongly attract each other. And when they strongly attract each other, they'll start forming the crystal back again. Okay? So most of these insoluble things, they've got very strong attraction. I mean, why is marble? Marble is a very strong material, right? So marble ko aap chamat se late ho na, it doesn't dissolve because the particles are really strongly attracting each other. So this is called precipitation. You'll start seeing solid precipitates forming and you'll get calcium carbonate as a precipitate. Okay? So you're going to get calcium carbonate as a solid. और पीछे क्या रह जाएगा solution के अंदर? The solution will have KCl, but it's going to be aqueous, which means that all the ions will be scattered. ठीक है? Is this clear?
Yes.
ये भाई आपको भी clear है कि नहीं?
Yes, sir. Okay.
चले अच्छा अब ये कि what do we do with this so we'll just do how do you explain this ठीक है the what are you going to write in your exam I mean the explanation for this is simple it's exactly you just mix I mean the first step will be mix calcium chloride aqueous with potassium carbonate aqueous. That's the first step. Now, once you've mixed, a precipitate will form. So what you're going to do is simply filter out the precipitate formed because we are looking for calcium carbonate. So filter out precipitate. You call it PPT precipitate is the solid. Okay? Filter out the precipitate that is formed. And since it's an insoluble precipitate, you're going to wash it with distilled water. So you're going to wash the precipitate with distilled water and dry in sunlight. Or between filter papers or in the oven. So that's it. Simple explanation. That's it. The only trouble is you just need to figure out what are your two reactants. So I'll do another one. Remember, insoluble salts are going to be made this way. You're not going to depend on the reactions that we did previously. So here's another one. Let's say I've got another insoluble salt, copper chlorides are all soluble. Let's say copper hydroxide. I want to make copper hydroxide. That's insoluble. That's a solid. So I want to make this salt. So I'm going to think, what I'm going to do is I'm going to think of the way I'm going to think about copper hydroxide formation is it's an insoluble salt. Okay? If you look at the solubility table, तो वहां पे लिखा हुआ है कि it's अच्छा वहां पे लिखा हुआ है कि all hydroxides are insoluble except the ones in group 1 and group 2, some in group 2, or the ones that are at the bottom of group 2. उसके अलावा बाकी सारे insoluble, and copper is a transition metal, so it's insoluble. So what did I teach you? I told you that you need two things. You need two things. You need a compound which gives you copper, and you need a compound which gives you OH. And then I told you that both of them must be soluble. They must be dissolved in water. So how would you, which compounds are soluble? I mean, I need a negative ion to go with this. Remember, nitrates are all soluble. उसके अंदर लिखा हुआ है solubility table में all nitrates are. So I'm going to go with copper nitrate. Or OH minus 1 के साथ I need a positive ion. तो वहां पे लिखा हुआ था all group 1 compounds are soluble. So I'm going to put Na in its next to it. So basically I've got copper nitrate and NaOH. So my solution, the moment I mix them together, because all of them are soluble, my solution will have all these ions floating around, copper ions, nitrate ions, and it's going to have Na ions and OH ions. So copper and OH ions, they form something that is insoluble, so that will settle at the bottom as a salt, as a solid salt, as a precipitate. Solution में Na, group 1 के सारे compounds soluble हैं, so Na and NO3 remain part of the solution, and they're going to be aqueous. ठीक है, is this clear?
Yes. Sorry, could you go a bit up to the how would we write it in the exam again for a second?
ये वाला part Krishna.
जी.
Just mix these two together and filter out the precipitate that is formed, and then wash the precipitate with distilled water and dry in sunlight. ठीक है.
Okay, thank you.
अच्छा, अब ये कि क्वेश्चंस करते हैं तीनों मेथड, ठीक है। विल जस्ट डू क्वेश्चंस, एक से मैं सेटअप कर लूं। अच्छा, जस्ट क्वेश्चंस, होल्ड ऑन अ सेकंड। क्वेश्चंस, ठीक है। सॉल्व प्रिपरेशन ओनली, ठीक है। जस्ट रिमेंबर यू नीड द हेल्प फॉर सॉल्वेबिलिटी टेबल, एसिड्स के नाम वगैरह, ठीक है। रिमेंबर देयर फोर रिएक्शंस, metal plus acid, metal oxide, hydroxide plus acid, and so on. Just like yes, always okay. And salt preparation. Just again. ये वाली हाँ, ये वाले। So just preparation of salts, ठीक है, this one. So let's start with this one, the first one. Calcium chloride, right? So he's saying pure dry crystals of calcium chloride from an aqueous solution. अच्छा, ये तो उसने he already did that. He's saying make crystals of calcium chloride, which is crystals का मतलब is solid. From what? He's saying that make it from an aqueous solution of calcium chloride. So that means the salt has already been prepared. So you're not actually preparing the salt. The only thing is asking for in this question is just crystallization. You've got an aqueous solution. The only thing you're going to do is you're just going to crystallize it. So how are you going to crystallize it? Evaporate calcium chloride aqueous to saturation point. And after that, cool gradually to obtain crystals. And once crystals are formed, ठीक है, ये पता है इसका मतलब क्या होता है कि usually you have a very dilute solution, so you've got very few particles of a salt. You evaporate some of the water. Saturation point is, so the salt particles would become very close to each other, and they'll start joining up and they'll start forming the crystal. But it takes a bit of a time. So cool gradually to obtain crystals, filter out the crystals that are formed. And then dry those crystals in, let's say, sunlight. अच्छा, तो इस वाले के अंदर ना, इसके वाले के अंदर तो आपने कुछ खास करना ही नहीं था, ठीक है। वो उसने सब कुछ आपको करके ना दे दिया था। अच्छा, the next one. Now he's saying aqueous sodium hydroxide reacts with FeSO4. Construct the ionic state symbols for this reaction. And the first thing is he's saying that NOH. So NOH reacts with FeSO4. Now this one is, okay, if I go back, NOH and FeSO4. A metal hydroxide reacts with an acid, so it's not that reaction. It is an ionic precipitation reaction. Group 1 compounds are all soluble. FeSO4 का क्या सीन है? इज इट सॉलेबल और नॉट सॉलेबल? तो FeSO4 का जरा जाके देखो ना कि क्या लिखा हुआ है, और सल्फेट्स में देखना, ठीक है? So if we go back and where's our solubility table? So have a look at FeSO4 somewhere. FeSO4 इसमें होगा, सल्फेट्स वाले में क्या लिखा हुआ है? That all sulfate salts are soluble except for these 3, 4. So that means FeSO4 is a soluble. It's a soluble salt. So it's also aqueous. अच्छा, अब ये वो एसिड वाला रिएक्शन तो है नहीं, it's not that reaction, so it must be the ionic precipitation reaction. So now you imagine your solution floating around are what ions? Na ions, OH ions, Fe+2 ions, and you've got SO4-2 ions. Okay, do any of these ions, so all these ions are randomly floating around in water in different directions, and they'll be bumping into each other. इनमें से दो ions हैं which if they combine they'll form a precipitate. It's Fe and OH. Fe and OH, if they combine together, they will form a solid precipitate because it's insoluble. Hydroxides कौन से soluble हैं? Group 1 के soluble हैं, Group 2 के bottom वाले soluble हैं. उसके अलावा बाकी सारे, all of them are insoluble. So FeOH2 solid precipitate is going to get formed. And what's going to remain in the solution is Na and SO4. वो precipitate नहीं बनाएंगे क्योंकि Na and SO4, it's going to be Na2SO4. Group 1 compounds are soluble, so they'll stay in the solution. They'll all remain dissociated. So that's your equation. Is that clear, this equation? Am I clear part?
Yes. Yes,
so
sir.
so that's going to be and you can balance it. It's 2 OH ions, so there's going to be 2 NaOH. 2 NAs, balance, I think. The next one is, he's saying that iron powder and sulfuric acid can be reacted to form, so give the practical details. The practical details is, not sure if he's asking or looking for an equation, but we're going to make an equation anyway. So if he reacts with H2SO4, salt will be produced and H2 gas will be produced. The salt is going to be FeSO4. And that's a soluble salt. We just did that. SO4 sulfates के बारे में क्या है कि वो सारे soluble हैं, except के ये लिखा हुआ है sulfates के बारे में, they're all soluble except for lead, barium, and calcium, right? Otherwise, they're all soluble, so it's aqueous. Sulfuric acid is aqueous. Iron is a solid. कौन सा method होगा? Insoluble reactant making a soluble salt. What method is going to be used?
The excess one.
The excess one, and this is going to be added in excess. So what you're going to do is add excess Fe into sulfuric acid, and keep adding until it remains undissolved. उससे होगा कि sulfuric acid is all going to completely react.
And then filter?
Yes.
Yeah,
So
to remove the excess, right?
yeah, so you add it in excess so that one of the reactant gets completely used up. The extra Fe, excess Fe is removed by filtration. Now your solution only has the product, which is FeSO4. So evaporate the solution to saturation point, you crystallize this. So it's pure dry crystals ka hai na? So you're going to focus on that. So last part is evaporate the filtrate or the solution. Filtrate is the solution that remains after you've actually filtered iron out. Evaporate the filtrate to saturation point. And next thing is cool gradually. So cool gradually to obtain crystals. And once you do that, cool gradually to obtain crystals. The other thing is filter out the crystals and dry in sunlight. So that's your excess method, okay? So you're going to write all of that in the lines that are given above. Okay, clear?
Yes, sir. And how many marks was this?
What's your question?
How many marks was this?
This was 3 marks.
Okay.
I said this was 3 marks. The previous equation was 2 marks, so total 5 marks, right? Now here's
Okay.
another one. Here's another one. I said there's a thing called ionic equations. We didn't actually do the ionic equations, but even in the previous one, he didn't actually ask for the actual equation. He was asking for the ionic. I mean, over here you can see that he wanted the full equation. Sorry, the ionic equation. So let me just tell you quickly what's the ionic equation. The ionic equation is that the ionic equation is that you remove spectator ions. So now your ionic equation is we can't see the NaOH plus what was the NaOH plus FeSO4, right? So it was NaOH plus it was FeSO4. And the product you had was FeOH2, that was the solid insoluble compound. What's left in the solution is NaSO4. So this was my solid. This was my aqueous. And I guess this was aqueous as well. So what happened was that two aqueous things, they would end up forming a solid precipitate. Now, what did I tell you about aqueous? I told you that when something is aqueous, uske jo ions hote na, they're all dissociated. They're all just roaming around freely in all directions, right? You clear? ठीक है, ये बात clear है कि if I say NaOH is aqueous, that means its ions are separate. Is that clear?
Okay.
अच्छा, so its ions are separate and completely dissociated. Now, same thing with FeSO4, that's also aqueous, so it's going to be Fe plus 2. And SO4 minus 2. Or ये भी aqueous. So I've dissociated its ions. The ions are separate. FeOH2 is a solid. So उसका मतलब है that's forming a crystal, so its ions are together. And Na2SO4 is also aqueous. That means 2 sodium ions will be roaming around separately from the sulfate ions. So all that I've done is I've dissociated substances that are aqueous. And I've kept the substances that are not aqueous in the same state. Solid means the particles are together and they're forming a crystal. That's what your solid means, right? So you clear ये part?
Yes.
So this equation, the equation that I've written in dissociated form, it's got some spectator ions. Spectator ions are the ones which are on both sides exactly the same. Basically, what is happening is they're not doing anything. You got sodium ions and you got sodium ions on this side as well. So then they're kind of not doing anything. So ionic equation is that you remove the spectator ions because they're not doing anything. So writing them is kind of pointless. Just a math equation. If there's an X on the left side, there's an X on the right side as well. Just get rid of the X because it's not doing anything. Is that clear?
Yes.
So finally, your equation is 2OH minus 1 Fe plus 2, and your product is going to be, what's your product going to be? It's going to be FeOH2 or solid. तो उसने वहां पे ना आयोनिक इक्वेशन लिखने को कहा था, तो ये लिखनी थी वहां पे, ठीक है? तो लेकिन हम प्रैक्टिस कर लेंगे, we'll practice this more. But is this clear, the idea of ionic equation? The only thing is you've got an equation and you can do this for any equation. कोई भी equation उठाओ ना, you can write an ionic equation for this. For example, I can do it for this one. All I need to know is I need to know the state of the reactants. NaOH group 1 compound, they're soluble, so that means my sodium ion and OH ions वो पानी में ना अलग-अलग घूम रहे होंगे. They'll be separate from each other, they'll be dissociated. HCl is an acid and that is also aqueous. That means H plus 1 and Cl minus 1 are separately roaming around. अच्छा, फिर ये कि last one, NaCl is also aqueous. That means Na plus 1. NaCl is soluble. So pani ke andar the ions are separate. Water is water, right? So what has happened is I've dissociated NaOH because it's soluble. I've dissociated HCl. I've dissociated NaCl. So the spectator ions are Cl is not doing anything, Na is not doing anything. So पीछे end में क्या equation रहेगी? It's just OH minus 1 and H plus 1. And together they are forming water. Is that clear?
Yes.
So खैर उसी पे करते हैं और practice, ठीक है? फिर वो क्या, construct the ionic equation between copper carbonate and hydrochloric acid. So I'm going to first make the whole equation. Copper carbonate plus hydrochloric acid, HCl. क्या बनता है? It's going to form copper chloride. Cu is 2 plus Cl is minus 1, so plus water plus carbon dioxide. And we can balance it. Okay, he's not asking for this equation, he's asking for the ionic equation. So ionic equation will be, ये जो कार्बोनेट होते हैं they're all insoluble, ठीक है? अगर वो टेबल देखो ना, solubility वाला किधर गया है? उसमें कार्बोनेट जाके देखो तो कार्बोनेट्स are all, वो ब्लू में अंडरलाइन भी किया हुआ है, कार्बोनेट्स and phosphates are mostly insoluble except group 1. So definitely insoluble solid. HCl is an acid. Acids are always in solutions. Chlorides are all soluble, so that is also aqueous. Water is a liquid and CO2 is a gas. अब copper carbonate को dissociate नहीं करना because it's a solid. That means its ions are together. HCl is aqueous, so that means the H plus 1 and the Cl ions are no longer together. They're scattered in water. Copper chloride is also soluble, so that means the copper ions and the 2 Cl ions are no longer together. और फिर आपके पास water और carbon dioxide है. So इसमें Cl ion is basically a spectator ion. It's not doing anything. Is that clear? जो बाकी equation बच गई है ना, that's your ionic equation. ठीक है, clear?
Yes.
So that's your ionic equation.
Sir, can I be excused for a second?
ठीक है.
Thank you.
आवाज आ रही है?
Yes, sir.
So again, it's going to be the method that you're going to use is going to be excess method because insoluble reactant and the salt that you're trying to make is a soluble salt. The excess method में क्या था कि add copper carbonate in excess to hydrochloric acid. And how would you know it's in excess? Because, and keep adding until it remains undissolved. बच जाए इनमें. उससे क्या होगा? Hydrochloric acid completely reacts. Filter out the excess calcium carbonate. So if you're using pieces of marble or chalk, you just take it out, filter calcium carbonate out. Once you filter out, crystallize the remaining solution because the remaining solution contains your salt. So evaporate remaining solution to saturation point. And cool gradually. And filter out crystals that are formed. Okay, that's it. So, what typical excess method question, okay? Clear है?
Yes, sir.
अच्छा, अब ये कि this thing makes zinc nitrate. Zinc is +2, NO3 is -1, so it's going to be zinc, NO3 twice. From zinc oxide, zinc metal oxide. So, what acid should I use in this case? ZnNO3 बनाने के लिए what acid should be used? I mean, which acid contains NO3? Anybody any idea? Like यहाँ पे board पे ना it's going to be nitric acid because it contains NO3. So it's going to be nitric acid or zinc oxide, metal oxide reacts with acid to produce salt and water. So that's going to be your equation. You can balance it. And again, if you look at the solubility table, oxides and hydroxides are only soluble for group 1 and 2. Otherwise, they're insoluble. So insoluble reactant, NO3 के सारे compounds soluble होते हैं. So that is aqueous. So you're making a soluble salt from an insoluble reactant. So again, excess method. Okay, add ZNO in excess to nitric acid and keep adding until it no longer dissolves. Until it no longer dissolves, filter out the excess ZNO. And evaporate the remaining solution to saturation point. cool gradually to obtain crystals. And once you obtain crystals, filter out crystals and evaporate. And dry in sunlight, ठीक है? चले ठीक है. तो मैं यहाँ पे end कर रहा हूँ, ठीक है? We'll continue with this. We'll do some more past paper questions about salt preparation. Just make sure you जो board पे ना everything that we did, ठीक है? That's crystal clear to you, ठीक है?
Right.
Sir?
हाँ जी.
Yeah, could you send the board link? The one you sent before, it's of the old one. It doesn't have any of this stuff.
Just a second. CM भेजो. User group पे भी post कर देना because somebody is just a second. I'm sending it in the chat over here. ठीक है? तो चलो
Okay,
ठीक है.
sir.
We'll continue with this, ठीक है? In the next class. चलो. Okay. Allah Hafiz.